Okay, that's April 8th, and we start our lecture. Go to quadratic equation and other nonlinear equations and inequalities. So, in your book. So, solving quadratic equations by the square root method. So, what is quadratic equation? An equation in which at least one variable term is raised to the second power, and no variable terms has power more than 2 or less than 0. Right? Okay. So standard form of quadratic equation is this: ax squared plus bx plus c is equals to 0, where a, b, and c are real numbers and a more than 0. Right, so if it's not, so you times -1. Okay, so let's do this simple task. So for a, we need to switch this to, right, 3x squared plus 5x minus 3 equals to 0. That's pretty basic and simple stuff, right? B. So what we have? You have minus 2x squared plus 7x minus 8 equals to 0. Now what I need to times -1, and I have 2x squared minus 7x plus 8 equals to 0. Okay, because a, the highest coefficient, has to be more than 0. Okay, right there. Now c. So what I have, 7x squared minus 4x minus 12 is 0. Good. I just take 12 to the other side and that's it. So d, I have 7x squared minus 3 equals to 0. Here b is 0. We don't write that. So 7x squared plus or minus, it doesn't matter. 0x minus 3 equals to 0. But we write like that. We don't write. Okay, good. So try this one. Right? So I just take everything from the right and transfer it to the left, and that's it. So I identify the coefficients of the quadratic, linear, and constant terms of a quadratic equation. So the standard form of quadratic equation, this one, has 3 types of terms. There's the quadratic term, linear term, and number term or constant, right? So complete quadratic equation, that all terms are there. Incomplete quadratic equation, when you don't have constant term, so c is 0. And pure quadratic equation, when you have a quadratic term and constant. If c is 0, x is 0, just one solution, right? So, okay. Write each equation in standard form and identify a, b, and c. Do I have next page? No, I don't. So I have to be tight. So a, it's already standard form, right? So a is 3, b is 5, c is -2. Yes? Let's alternate colors so we have something. B. So 5x minus 2x plus 3 equals to 0. That is standard form. And a is 5, b is minus 2, c is 3. Good. So c, 5x squared minus 3x equals to 0. So what is it called? Incomplete quadratic equation. How we solve it? Take x outside. One or solution always will be 0, right? That we come to that. So a is 5, b is minus 3, and c is 0. Yes? Okay. C, D. So I need to multiply on minus 1, so 6x squared minus 2x is 0. So a is 6, b is minus 2, c is 0. Sorry. E. So it's what? It's pure quadratic equation, right? A is 5, b is 0, c is minus 4. F. So x squared minus 9 equals 0. So a is 1, b is 0, c is minus 9. G. X squared minus plus 3x minus 5x equals 0. So x squared minus 2x equals 0, right? And a is 1, b is minus 2, c is 0. Finally, h. So what I have, minus x squared. Actually, I can transfer that to other side right away. So x squared plus x plus 3 minus 7 equals 0. So x squared plus x minus 4 equals 0, and therefore a is 1, b is 1, c is what? Minus 4. Good? Very nice. Try this one. So what do we have here? 3x squared minus 2x minus 7 is 0. Means a is 3, B is minus 2, C is minus 7. 2, 3x squared minus 7x equals 0. So A is 3, B is minus 7, C is 0. So it's incomplete, right? 3, 2x squared minus x plus 2x minus 5 is 0. So 2x squared plus x minus 5 is 0. And A is 2, B is 1, C is minus 5. Finally, x squared minus 16 is 0, so it's pure quadratic equation. A is 1, B is 0, C is minus 16. Good. So solve pure quadratic equations. So we will do step by step, learning how to deal with that. By square root method. Square root property of equality. Equality is maintained if the square root is taken of both sides of the equation, right? So if we have that pure quadratic equation, we rearrange the equation if necessary so that the quadratic term is on one side and the constant is on another side of equation. Combine like terms if appropriate. We write the equation so that the quadratic term has coefficient plus 1. That's important step. Okay, so A has to be 1, positive. Apply the square root property of equality by taking the square roots from both sides. Check each solution in original equation. So what we have here, y squared is 27 over 3, right? Because A has to be 1. So y is what? 9, right? Squared. Now, we have two roots. So remember, whatever the highest exponent of the equation, the same number of roots you will find. That's the golden rule. Sometimes roots are complex, but they are there. Okay? In case of complex roots, we say there is no real roots. Okay, that's what we say. Now, how we check? Minus 3 squared, 3 times minus 3 squared, so 3 times 9 is what? Right? So we always check with the original equation. 3 times 3 squared, 3 times 9 is 27. Good? So this one, 4x squared equals to 9. That's the first step. So then x squared is 9 over 4. As the second step, we need a is 1. Now x1 is negative 3 over 2. x2 is 3 over 2. If you check, 4 times negative 3 over 2 squared minus 9. So what is it? 4 times minus disappears, 9 over 4 minus 9 is 0. Yes? So 4 times 3 over 2 squared minus 9, 4 times 9 over 4 minus 9 is 0. Try this too. Okay, so what do we have? The first step, we need to what? Right? So x squared is 4. So x1 is minus 2. x2 is 2. So typically we arrange solutions from smallest to largest, right, as it goes on the coordinate line. So 25x squared equals to 9. That's the first step. Now the second step is this. So x1 is minus 3 over 5. x2 is 3 over 5. So we didn't check. 7 times minus 2 squared. Yeah, it is 28, right? 7 times 2 squared, it is 20. Here, 25 times minus 3 over 5 squared minus 9 is 0. So roots are fine, roots are okay. For basic equations like that, typically, everything's fine, right? Okay, so next step is solving quadratic equations by factoring. So zero product property, it's a very important part. So if you have product A times B equals to 0, then either A equals 0 or B equals 0. And we have to check both, are they 0 or not, right? So remember we factored the trinomials. So for the solutions, we need to make 0 equal each of the terms. So we have to factor it and make 0 each of the factor terms. So let's do it. So A, what I have, 2x squared equals 5x. Let's rewrite that in standard form. What I see here, C is 0, right? So it's incomplete. To factor it, I can take x outside of the brackets, and I have 2x minus 5. Correct? So now x1 is 0, x2 is 5 over 2. You know where 5 over 2 came from? Yeah, so let me do steps then. 2x minus 5 is 0, so 2x is 5, x is 5 over 2. Okay. So this one, B, 4x squared minus 8x is 0. So again, it's an incomplete equation, so x, actually 4x can be taken outside. So I have here x minus 2 equals 0. So 4x is 0, x1 is 0, because 4 is not 0. So x minus 2 is 0, x2 is 2. Try this too. Okay, so first one, 3x squared minus 6x is 0. 3x we take outside. X minus 2 is 0. So 3x is 0, x1 is 0. X minus 2 is 0. X2 is 2. So the second one, 8x squared plus 2x equals 0. So what we take? 2x outside. 4x equals plus 1 is 0. So 2x is 0. It means x1 is 0. 4x plus 1 is 0. So 4x is minus 1. X is minus 1 over 4. Good. So some tip. In an incomplete quadratic equation, the value of c is 0. So that's what it is. And basically that's what we did. One root is always 0. The other root is minus b over a. Just so complete quadratic equation by factoring. So what we do, we make sure it's in the standard form, then we factor it, then we make each factor 0 and find roots this way. Okay, so what we have here, a x squared plus 6x plus 5 equals to 0. So how can I factor it? 5 plus 1 or 3 plus 2? If I take 5 plus 1, what I have? Yeah, should work. Plus 5x plus x plus 5. So what I have? x plus 5 plus x plus 5 and x plus 5, x plus 1, right? So original equation, after I factor it, is this. So now I make x plus 5 is 0, so x1 is minus 5. X plus 1 is 0, x2 is minus 1. So let's do it. B, 6x squared minus 11x plus 4 equals 0. That's the standard form. Now what I have, 24, right? So 24, 6 times 4. No. Okay, let's do it this way. So 1 times 24 doesn't work. 2 times 12. No. Then 3 times what? Do we have, is it divisible by 3? 8? Yeah, 8. Is 3 working? 3 times 8? Looks like it, right? 3 times 8, so 6x squared minus 8x minus 3x plus 4. So what I take 2x outside, right? So 3x minus 4. Here I take minus outside, 3x minus 4. And therefore I have 3x minus 4, 2x minus 1. Yes? And my equation becomes 3x minus 4, 2x minus 1 equals to 0, and 3x minus 4 equals 0, so 3x equals 4, x1 equals 4 over 3, So 2x minus 1 is 0, 2x is 1, x is 1 over 2, x2. Well, so if you take first larger, second smaller, it doesn't really matter. But technically here, x1 is 1 over 2, x2 is 4 over 3. Okay, try this. What we have 3x squared plus 7x minus 6 equals to 0. 3 times 6, 18, right? So 2 times 9 will do, right? 3x squared plus 9x minus 2x minus 6 equals. So 3x I take outside. And here I have x plus what? 3. Here I take minus 2 outside. And I have x plus 3. So x plus 3, 3x minus 2. And therefore I have 3 x plus 3. X plus 3 times 3x minus 2 equals to 0. X1 is minus 3. X2 is 2 over 3. Eric, I think that's okay. I don't have to go baby steps anymore, right? So we pretty much know what is happening. So the second equation I have to rewrite first in standard form. So 10, so what is it? 2 times 5 will do 2x squared plus 5x plus 2x plus 5. So what I do, take x outside, 2x plus 5 plus 2x plus 5. So as a result, I have 2x plus 5, x plus 1, right? So 2x plus 5, x plus 1 equals to 0. So x1 equals minus 5 over 2. X2 equals minus 1. So some tip. Because all three types of terms are included in complete quadratic equation, the roots do not have the same characteristics as the root of the pure or incomplete quadratic equation. The characteristics of complete quadratic equations are: 0 is not a root. Okay? The two roots are not opposite sides. It means like you had plus minus 2, for example, right? X squared equals, so if you had x squared equals 4, so x1 is minus 2, x2 is 2. So that is what? Right? So in the full complete quadratic equation, it's not happening. So there can be just one distinct root. If an equation has two equal roots, the one distinct root is called the double root. So remember I showed you technique with D. So when D is 0, two roots are the same. It's a double root, called double root. Okay. Solving quadratic equation by completing the square or using the formula. Well, this one is interesting. So what is completing the square? That's a procedure for solving quadratic equation that is used most often when a quadratic equation cannot be solved by factor. Right? So this method incorporates manipulations that result in a perfect square trinomial that factors into the square of binomial. Look again at the relation between a perfect square trinomial and the square of binomial. That's formula. Remember? Okay, let's see. So here is long procedure. What is there with A, B, and C? You can read that on your own. Let's see how it works. So A, x squared minus 5x minus 2 is 0. So the first two steps are useful. The first step is to do this. So you take C to the other side, of course changing sign. Then second step, you need to make A 1. So you divide on A both, everything actually, right? So let's see. So x squared minus 5x equals 2. A is 1, so we okay, right? Now, I keep in mind that formula. Let me take different color. X squared minus 2x plus, well, 2x, 2bx, let's put this way. Okay, let me put the formula, okay? So what, okay, this one. So a squared plus 2ab plus b squared equals a plus b squared. Of course, if minus here, right? Now, I analyze, so I keep that formula in mind. Now, I concentrate on my left side. X squared minus what I have, 2 times 5 over 2x. Yes, I need double product. So now, let me highlight. 2ab, so a is x, it means b is 5 over 2. You see it? If I say that 2ab, that's the middle term, and I have 2 times 5 over 2 times x. So x is a because it's a first squared term. 2 is 2. So what is left for b? 5 over 2. Right? So now to complete that formula here, I need to add 5 over 2 squared. Okay? Now, in order not to change, if I add something to the left side, I need to add something what? To the right side. So 2 plus 5 over 2 squared. Yes? Now, what is the left side? X minus 5 over 2 squared. I created this formula. Yes, see it?
I mean, I see how you got there. I see the formula.
You see the formula. So a squared minus 2ab plus b squared. So, but because of minus here, I have 5 minus equals 2. Now, let's play with that. 2 plus 25 over 4. So x, okay, let me continue here. So what I have, 8 plus 25 over 4. What I have, 8 plus 25, 33. So x minus 5 over 2 squared is 33 over 4. Now, I have something in square here. I take square root from both. Let me go this way. Do I have page? Oh, I have page. Thank you, God. Thank you, Andrew. You made a page. So x minus 5 over 2 minus 4 yes, one time root is negative, one time root is positive. Okay, so x is what? 5 minus square root of the 33 over 2, x1, x2, 5 plus square root of the 33 over 2. Okay, let's try to plug the values. Okay, let's calculate. Let's make it easier for us. So here I have x1 is negative 0.3723. Here I have x2 oh really? Okay, one more time. 5 plus square root of 33. Yeah. 5.3723. Okay, so let's do the manipulation here. So, what? Okay, thank you. So what was it? X squared? Eric, you didn't write it. Okay, let's see. Minus 5x minus 2. Zero, 3, 7, 2. 5, 3, 7, 2. Good? Okay. So roots are calculated. So let's practice the other one. So 3x squared. Let's do this and have a break, okay? 3x squared, what was it? Minus 3x minus 7. Minus 3x minus 7 equals to 0. So what is the first step? I take 7. Well, it doesn't matter. I divide on A or take 7 on other side. Let's stick to that procedure. Then what? I divide on 3 in order to make here 1. Oops. Now, I keep in mind, so what I write? X squared minus 2 times. But here I have 1, right? So now I have 1 again. Correct? Now, so what is B here? 1 over 2? So 2, it's a double, it's 2. X is A, it's a first square. So whatever is third factor is B. Do you see this? Okay, again. So if I want to have this, I need to create this, right? So A squared is always X. A is always X here. Now, what's the second term? 2AB. What I have here, 1. I need 2, right? But I don't want to change that value. So in order not to change the value, I have to multiply on 1 over 2. This way, value is not changed and I'm fine, right? Now, the middle term looks 2 times A times B. Because X is A, 2 is 2, so 1 over 2 is B. Therefore, for this second square term, 1 over 2 is a perfect candidate.
That's fine. I understand like where B goes. I just didn't understand how to get.
Well, from here. From here. Now, I added this to the left side. So in order not to change the fraction, I need to add this to other side. So on the left, I have x minus 1 over 2 squared. I have that formula. On the right, what I have? 7 over 3 plus 1 over 4. Let me just continue here. What is this? Common denominator is 12. So what is it? 28 plus 3, right? And I have what? 31 over 12. And as a result, I have this. Now, if I want to take a square root, so 31 is 31. Nothing can be manipulated. Here is 4 times 3, right? Yes, got it? So that's first, or I have positive. Now, x is what? 1 over 2 minus. So x is common denominator 2 square root of 3. And I have square root of 3 minus square root of 31. That's the first root. Then, oh, let's do it here. 1 over 2 plus, so what I have, 2 square roots of 3. And here I have square root of 3 plus, okay, let's calculate that music. Square root from 3 minus square root of 31 divided on 2 divided on square root from 3. So minus 1.107 x2 square root from 3 plus square root from 31 divided by 2 divided on square root from 3, 2.107. Ready? Moment of the truth. So 3x squared minus, I said minus 3x plus 7, right? Was it minus 7? Yeah, minus 7, because otherwise we won't have a root. Right. So minus 1 plus 2. Good? Okay, so it means practice, right? Practice, practice, and practice. Okay, let's have a break. Okay, break is over. Let's see. So let's do it together, right? So we manipulate and so we keep in mind that formula. Right? So the main manipulation, what we do is here. So let's start. X squared plus 3x equals to 1 as the first step. Now, I check, do I have one, a equals to 1? Yes, I do. Now, x squared, so now I refer to the formula. 2 has to be here, 2, right? Then I have 3, 2x, let's put it this way, 2x, which is 2a. Now, I need 3. Okay, let's do it separate. 2x times 3 over 2. 2 and 2 cancels out. I have 3x. right? So basically, I create fraction to eliminate 2. That's the manipulation here. Why? Because I need 2 for 2. X stands for A. 3 over 2 stands for B. Got it? So basically, I'm creating that formula, right? So do I need 2? No, according to the formula, do I need 2 to be here? Yes? Yes. Now, what's the second multiple? A, right? What is A? What serves for me as A? X? So 2x. Now, what I have? 3x? Well, so this 2 is kind of, so 3 over 2. When I simplify as I did here, I still have 3x. So with this manipulation, I didn't change this. Got it? Okay, so now I add b squared, which is 3 over 2 is b. Now if I add it to the left side, I should add it to the right side. So x plus 3 over 2 squared equals 1 plus 9 over 4. I just continue here. What is it? 4. 4 plus 9, it is 13 over 4. And therefore I have x plus 3 over 2 squared, it is 13 over 4. Now when I take square root from both sides, I have x plus 3 over 2 equals minus root from 13 over 2, or x plus 3 over 2 equals plus root of 13 over 2. So x is minus 3 over 2 minus root 13 over 2. So or x is minus 3 over 2 plus root 13 over 2. Now, what I have here, negative 3 plus square root of 13 over 2, that's x1, x2. I have 13 minus 3 over 2, right? Now let's calculate. Why? Because we want to double check, right? So 3 plus square root from 13 divided on 2, negative 3, 303. So here, square root from 13 minus 3 over 2. Okay, let me double check because I don't want, okay, everything's fine. Over 2, so x2, 0, 303. Okay, what I have, x squared plus 3x minus 1. X squared plus 3x minus 1. Good. So now, do you want to try the second one on your own? Okay, so let me write this down. 2x squared minus 9x plus 3. Okay, try. Okay, let's do it. So very important to do it at least once by yourself, right? So what is the first step? 2x squared minus 9x equals minus 3, right? Then we divide everything on 2, and I have x squared minus 9 over 2x equals minus 3 over 2, right? Now, x squared minus 2 times 9 over 4 times x plus 9 over 4 squared equals minus 3 over 2 plus 9 over 4 squared. Now what I have here, x minus 9 over 4 squared equals, and here I have 81 minus, what is it, 16? And 3 times 8 is what, 24? So x minus 9 over 4 squared equals, so I believe 57, right? Good? You got the same? Okay, so x minus 9 over 4 equals negative root from 57 over 4, or x minus 9 over 4 equals positive root of 57 over 4. So x is 9 minus root of 57 over 4. X is 9 plus root of 57 over 4. Now let's calculate. 0.363. $4.137. Okay, the moment of the truth. Minus 9x plus 3, right? Is it? Exactly the same thing. So we're good. You see, we become, slowly but surely, we become masters. Okay. Solve quadratic equation using quadratic formula. So that's quadratic formula. I prefer, that's my opinion, and not only mine, but split in two steps. D equals 2 b squared minus 4ac. So basically, that is what? D, right? And now the second step, x1 comma 2 is minus b plus minus square root from d equals divided on 2a. So why so? The moment I evaluate d, I have three options. Option 1, d is more than 0. So I have two solutions. Option 2, d is 0. So one solution, right? Oh, two solutions, they are the same, right? So one solution. How do you call it there? Let me see. Where we had that? Right there. Double root. Yeah. Okay. One solution, double root. Right? So double root. And 3, d is less than 0. No real solutions. What does that mean? That graph doesn't cross the axis, right? So that's why I prefer this two elements calculated. So not to go and jump right away to that formula, just calculate d first and then you see where you are. Make sense? What to expect. Okay, yeah, procedure is, so write in the standard form, identify ABC, substitute numbers, yada yada. So let's do it. So A, 1, B, 5, C, 6. And you remember we consider sign, right? So first step, D, B squared minus 4AC. So 5 squared minus 4 times 1 times 6. 25 minus what? 24 is 1. So x1 equals minus 5. Okay, let's put it here. x1, 2. Let's put formula just for now. So we memorize that. x1 comma 2 equals minus b plus minus square root from d over 2a. So x1 minus b is minus 5 minus 1 over 2 times 1. So what I have? Minus 3, right? X2 minus 5 plus 1 over 2 is minus 2. Questions? Now, for example, if I want to factor it, what I do? Because the factoring happens like that. A. But A is 1. So let's double check. X squared plus 2x plus 3x plus 6. Good. Okay, try this one. Okay, so what is step? Yeah, for start, let's identify A, B, and C. 6, right? So D, B squared minus 4AC. So 5 squared minus 4 times 1 times minus 6. Okay, let's calculate that. 5 squared minus 4 times minus 6. It's 49. 49, it's a perfect square from 7. I can write like that, so I already know the square root answer, right? So x1 comma 2 minus b plus minus square root from d over 2a. So x1 is minus b minus 5 minus 7 over 2. So what is it? It's minus 6, right? X2 is minus 5 plus 7 over 2 is 1. So probably you notice I always take minus d first. So it makes me first root smaller, right? Okay? So use quadratic formula to solve equation for x. Okay, d. Okay, let's do this way. A, 3, b, minus 3, c, minus 7. So d equals b squared minus 4ac minus 3 squared minus 4 times 3 times minus 7. So let's do it. 3 squared minus 4 times 3 times 93. There is no perfect square from 93. Square root, right? Is it? Let's double check. Yeah. So x1 comma 2 is minus b plus minus square root of d over what? 2a, right? So x1, 3 minus minus 3 minus square root from 93 over 2 times 3. So let's calculate that. 3 minus square root of 93 divided on 6 minus 1.107 x2, 3 plus square root of 93, 2 times 3. So 3 plus square root of 93 divided on 6, 2.107. Okay, let's, I think we had this equation before. So 3x squared minus 3x minus 7 minus 1.107, 2.107. Good? Very nice. Okay, try this one, Terry. Okay, so what I have, A is 2, B is minus 9, C is 3. D, B squared minus 4AC, so minus 9 squared minus 4 times 2 times 3. Let's calculate. 57. So x1 comma 2 is minus b plus minus root from d over 2a. So x1 is minus b is 9 minus root of 57 divided on 2 times 2. So let's do it. 9 minus root of 57. Seems to me we had that already, right? Nine plus root of 57 divided by 4. So let's double check. 2x minus 9x plus 3. 2x squared 3. So what I have? 0, 3, 6, 3, 4, 1, 3, 7. Exactly what we calculated with the formula. So find the length and width. So some fairy tale story of a rectangular table if length is 8 inches more than width and the area is 260. So rectangle. So if it is x plus 8, that is length, right? So area, what is area? So 260 equals x plus 8. Now let's open brackets. X squared plus 8x minus 260 is 0. So what we want? Formula? Let's do formula, right? So d, or we want full square. Well, let's do both. Let's do both. So we started with d. What I have, 8 squared minus 4 times 1 times minus 260. So 8 squared minus 4 times 1 times minus 260. Well, I don't have any perfect square roots here. Okay. So x1 comma 2 is what? Is minus b plus minus square root from d over 2a. So x1 is minus b is minus 8 minus square root of 1104 over 2. So okay, minus 8 minus square root 1104 over 2 minus 2613. Is that acceptable for us? No, because we're talking about dimension of a table and it has to be positive. Okay, so it is root of the equation, but it's not the solution of our question. So x2 is minus 8 plus 8 plus 11 4 divided to 12. 6132. I prefer for most of the parts 4 digits. So then that is what? With then 126132 plus 8 equals to 206132. It is length. So let's manipulate with what? With the equation here. So x squared plus 8x equals 260. So x squared plus 2x. Now I need this. So here I have x plus 8 over 2 squared equals to 260 times 4, that's 1040, plus, oops, 64 over 4. So what is it? 1104 over 4. Yes? Yes. So x plus 8 over 2 is minus. Oh my God. So x is as you see, you have exactly same thing, right? Should we check that on the graph? Be good, right? So I think next practice we will leave for the next time, and be done for today. So I uploaded PowerPoint and practice exercises online. So go for it.